right. Yeah, I think we're right at three guys, so I'm gonna get started. Um, so again, we're getting there. All we have left, let me grab math practice first. We only got a couple more homeworks to go. I think we're gonna do regression analysis will be homework today. It's like probably the easiest homework of the whole course. And then we'll have a little homework on control charts when we get into the control phase. And then we'll get into the exam. Like we'll do a review first. And then I'm thinking, let's see, probably 16, maybe four teams of four, something like that, to do a project, take a week or two, grab a data set, apply some tools to it. I'm going to send you some examples of some of the past presentations. I have a whole bunch of videos of, people doing the presentation. So I think the first thing I'm probably going to do is pick kind of captains, for those four teams. And a lot of times we'll do it with cross company. So you're working with people from other companies, which has been kind of, I think, fun. This is the feedback I've gotten. So anyway, we're gonna have 2 weeks. This is the second week of Improve, and then we're done. And then 2 weeks of Control, and then we're done. And then you'll be the owner of a certificate that's suitable for framing and a mug suitable for drinking. So I want to get into real quick I know I didn't get the homework from everyone yet on correlation, but I'm going to switch over to, yeah, that's Devin's homework, and it's perfectly done. And you could see that, when you got a mess like this, it's still not zero, right? But it's a very, very weak positive correlation between my weight and my pulse. Right. So I'm not going to be able to make too many predictions based on this. So in other words, the idea of a prediction, in which we're going to get in today with regression, is if I put in a weight, say, 181, it should come up with, if I have a good correlation, it can predict for me what my pulse rate is going to be. So that's kind of cool, when you're doing improvement work. Once my process is somewhat under control, I have a couple of variables that are correlated. By changing one, I could change the other. Remember that y is a function of x's. So yeah, this is what it's supposed to look like. And then the data pack, um, there's the Pearson's R for that. So I wanted to kind of switch over and get into a little regression stuff, which is kind of fun too. Did I do it already? No, I did not. Okay, that's fine. So we looked at last time, age versus salary. So the homework is going to be, again, it's probably the easiest one of all. So all I'm going to ask you to do here is, we've already done the graph for weight versus pulse, and we're going to try a little bit of regression. And regression, all it means is, let me just go ahead and do one real quick for you. There's a couple ways to do it. The first way is with, I'll highlight my age and salary. I'm going to pull up a suitable graph by insert recommended charts. And there's the one we picked, right, last time. And from there, I think last time what we looked at was grab Pearson's R from this. This is kind of what you did from homework. So that's the trend line. And then way down here, I could display the equation on the chart and display the R squared value on the chart. And they just showed up. There they are. You guys can see those. Maybe the R didn't show up. Let me do it again. It must be on there somewhere. Anyway, we know what it is anyway. So what we're interested in today is regression. Because again, we're talking about being able to predict by having a data set and by having a number. Like, let's say I wanted to know, hey, at age 95, what would my salary be if this pattern, because definitely it's a strong positive correlation, right? Even though we know most of us are going to be retired by 95. But how would I know? What's the formula to predict what my salary would be based on this data here if I kept working, obviously, at age 95? And that formula right here, I'll make it a little bit bigger so you can see it. I think it's a little tough to see. Oh, there's the R squared, by the way. Let me make it presentable. There you go. So the first number, it says for every Y, which is the salary, it's going to be equal to this 1320.5, which is actually the slope of this line, the rise over the run. Like, what's the steepness of this line? And that's represented by this coefficient called 1320.5. And depending on the slope, it's going to be a different number. And I take that 1320.5 and I multiply it times whatever X I want. You know, it might be age, I don't know, 110, whatever, 99, whatever you want. And then from that product, I'm going to subtract 6627.7 minus 6627.7. What that is where does this line intercept the y-axis? So the x-axis is 0, 10, 20, 30, 40, 50, all the way to 70. And the y-axis is 10,000, $20,000 here. So basically the minus 6627, if I follow this line all the way down, it's going to be below zero here, right? It's going to be somewhere, it's going to be at 6627.7. And using that formula, I can plug in and actually predict, once I know that there's a correlation, a strong positive correlation between my two variables. In this case, very strong. I think what I'm going to ask you to do for the homework is kind of just duplicate what I just did. And I'm going to, which is largely just pulling up the formula. And there's a couple other ways to get these two formulas. One is equals slope. And then it's going to ask me the known y's and the known x's. The known y's are here, comma, the known x's. Yeah, why don't we do the pulse and weight? That'd be fun. Let's see what that comes out to. I've never done that. So there's my 1320.5. So again, that's my slope of the line, rise over run. That's the steepness of it. And then my intercept. Just type enter and it pops up. Double click it. Known y's. And comma. Known x's. How simple, right? There's my minus 6627.652. Now, a third way of getting this most valuable formula, because it allows me to predict, is using our old friend, the data pack. I'll go to data analysis. This is going to give us a lot more information. You'll see that there is there's a choice for regression. So let's click that. And it looks like I already did it. So I'm going to type in my Y range, which I did. You see the Y, and I included the labels. Those are checked. And then input my X range. That's the age. And I want to know with 95% confidence. And I'm going to put it at F34. I could put on a new worksheet if I want to. I could even put it in a new workbook if I wanted to. And then I want to look at, also include, what are the residuals? So the residuals are, what's the difference, the distance of all these data points that are not on the line? Here's my trend line. What's the average distance? What's the distance of all these data points off the line? And I may want to know that with large data sets. Hit OK. And I get this. So here I got, for this particular correlation, age and salary, I have R square. I'm interested in that. I'm interested in the y-intercept, minus 6627. I'm interested in the slope, which is 1320.5. And then here I have 10 observations. And let me double click this. And I get to see my residuals, which we're going to get into when we get into PowerPoint, or what my predicted salary should be if it was a positive correlation of 1, right? What's the difference? You know, so this is the actual difference between my predicted, and this is important because if we want to change a variable, temperature, heat, speed, whatever, and we're getting data generated, at some point we want to be able to predict. We don't want to just randomly have to keep shooting craps to get the zero in on the property we want. So this is a really cool tool. So what I'd like you to do for the homework is go ahead and do the slope and intercept, or that, what I showed you with Devon's, the weight and the pulse, which we know is a very weak. But let's go ahead and try it anyway. See what the formula looks like. Let's go ahead and do the data analysis pack. And yeah, any questions about this? I like this tool. It's fun. It helps us make data talk. Is that's the whole point. That's all we want to do. Yeah. All right. That's our math practice. This is going to be a fun class because we do like a little bit more of this, and then we get into some lean stuff, which is like really fun sport. So let me grab the presentation. And you guys have watched like 900 slides already, believe it or not. And I want to get into, so last time we covered how do we select improvements. We got into fishbone, and then we got into this wonderful tool, my favorite, correlation, and how to do a scatter XY diagram. Today we're going to cover regression, residuals, multiple linear regression. I'm gonna mention data transformation. That's not something that I would recommend. And then we're gonna get into stuff you guys already know, really. So some of it might be review. You can sit back, crack open a beer. I'll go through 5S, visual factory, standardized work, Kaizen, Kanban, Poke-OK, preventive maintenance, and Jidoka. So without further ado, this is a review. Simple linear regression. So it can't adjust the following. How much does one variable change when the other variable changes by 1 unit, right? That's not, it can't tell us that. How can we set the value of one variable, obtain a targeted value of another value? The correlation coefficient won't do that, the R squared, right? But this regression analysis does. How can we use the relationship between two variables to make predictions? And this is where regression analysis comes in. I don't know why they just don't call it that, making predictions. So simple linear regression, it's a tool to fit a straight line through data points. It's a line of best fit is another way to think about it, right? And we saw the line of best fit on that Milky Way of my weight and my pulse. Really difficult, but that's still a line of best fit given, the 800 pieces of data that obviously are probably not correlated very, very much. Doesn't matter what my weight is. It's almost zero, right? In terms of, but there is a slope there. So there is a weak positive correlation. And it models the quantitative relationship between the two variables. And there's our formula. And you can see that there's a C added on here for residual error. But it's perfectly fine just to do Y being the dependent variable, to be the salary, A being the slope, X being the independent variable, which would be my age, and B is the intercept, where we hit the Y axis. And in thinking in terms of ANOVA, analysis of variation, and because you do remember when we did the regression, using data packet, asked us for what confidence level we want to look at. So, you can do some hypothesis testing using these, all of this data, all of these tools. But basically, it's total variations, the total sum squares. And it's not, I don't think I really need to think too much about this one. Explained variation is the regression sums of squares, and the unexplained variation is the error sums of squares. We're not going to do any of that. There's the formulas for them. That's probably more black belt stuff. This is what we kind of looked at. So we have a predicted value, which is that line of best fit that got drawn through the data. And then there's the vertical distance, the unexplained variation. There's the explained variation, which is the SSR, and then the total variation. And that's kind of spelled out in the data analysis pack when we printed it out for the residuals. So the coefficient of determination, R squared, measures the proportion of variability in the data that can be explained. And so again, this kind of a little bit of a review, 0 to 1. It's R squared. It's the Pearson's R squared, really. So you got a positive number all the time. And you want to have a target of 0.73. If the target is 0.73, the corresponding R value is 0.85. So 0.73 squared is 0.85. The higher the R squared, the better the model. All right. So again, I'm not sure that I would want to try to do any kind of improvement activity based on my weight and my pulse. Maybe weight and blood pressure, which you're going to see, next. Maybe that might have a correlation, more direct correlation for that since 2006. And then residuals, we covered that too. Again, that's looking at how far we are off the line, really, right? So residual is the difference between the observed Y and the one that we expected from the formula, right? And there's the mean, and there's the observed value Y. And the residual formula, it produces the line of best fit, and difference between the predicted and observed are known as residuals. That's all it is. That's all residual analysis is. It's the differences between predicted, as we saw in the data pack, and observed. And why? Because the quality of linear regression should be assessed by defining residuals and examining the residual plots. And the values of both sum and mean of the residual are 0, indicates equally balanced distributed on both sides of the regression line. We want it to be, we don't want a lot of outliers, all around, like we saw with my weight and my pulse. So the requirements are, the equations are generated on the basis of certain assumptions. Residual analysis helps to determine the validity of these assumptions, and the assumptions are that the residuals are normal distributed. So we measure the residuals, we treat that like a data set, and that data sets are normally distributed. So we don't have a lot of special cause of variation there. The residuals are independent, the residuals have a constant variance, and they're linear. This is not on the exam at all, so don't worry about this. Just an explanation of some of, kind of getting into the residuals a little bit deeper. If it doesn't meet the requirements, we need to rebuild the model by replacing the predictor with a new one, adding new predictors, building nonlinear models, etc. Because we don't want to make bad predictions, right? So this is all a way to see if we were able to make good predictions based on the data we had. And multiple linear regression is evaluate multiple inputs. So not just age and weight. I'm sorry, age and weight and pulse. It might be weight, pulse, and diastolic blood pressure, or whatever, calcium concentration in my veins, whatever. If R squared is not as high as desired in a simple linear regression, then we can do this. So we add another variable to it, right? We can't just rely on pulse and weight. But the simple linear regression assumptions stay the same, all right? And then data transformation, all I'd like you to know about this. There's nothing on, I keep saying there's nothing on an exam. You guys are saying, man, is there an exam? But anyway, this is basically just turning data that's not normal and being able to turn it into something that works like normal by making equations out of it. I'm going to jump right to, and here's the kind of some rules for it. Preserve the relative order of the data, must be smooth and continuous. So you apply it to all the data. It's useful when the ratio of the largest to smallest is greater than 2. And the cons are difficult to understand transform units, difficult without automation or computers like Minitab. And we don't cover this. Never used it, but basically it's about transforming non-normal, non-linear data into something I can treat like normal. Because think about all the advantages of having normal data. I can predict. So it might start out like this, and then I end up with somewhat of a bell-shaped curve. That's the impact of data transformation. All right, enough's enough. Down the stretch we go for the improve phase into lean. So here, like church, this is where we start. The objective is how do we create flow in all 2,000, 3,000 processes in your company, right? Everything from how do we cut a check to how do we receive material, how do we hire someone, how do we test our materials, how do we receive raw materials, how do we cut a check, everything. How do we pay our employees? And the idea is, lean is time management. So if it takes us 10 minutes, let's figure out how to do it in 8 minutes. And then when we do that, let's try 5. And the idea is it's really a growth strategy because I was with my friends at Marion last week. Unfortunately, there's only 2 things you do if you're in business, and that is you're either growing or you're dying. So there's a couple of different ways to grow. You can stay still and keep your processes the same, and then just double them, right? Make them do twice as often because you got more orders, more raw materials coming in, more invoices, more checks, whatever, and just throw bodies at it. Or you can prepare for growth by taking a real hard look at those 2,000 processes and trying to recognize these 8 things, all called non-value added work, things that we take out of our processes. And you just remember downtime. And I think I always like to talk about the fact that overproduction is the mother of all waste because it causes all the others. If I'm making more than I need right now, it could be I'm buying more than I need right now. That's a process, right? Or I'm just making more and putting it in inventory. Then it causes all the other things because it creates inventory. I have to move it, transport it. I have to pay somebody to move it. It could get damaged while it's sitting there. Materials are waiting. The money is waiting in the bank. So overproduction is the mother of all the waste. And lean's as simple as it's time management and it's reducing the amount of time it takes to do every single one of our processes by first learning how to see these. And this is where mapping and other lean tools come in because you can only see so much waste with your naked eye. Then you have to start using tools. And here's some examples of some lean concepts that are used to improve the overall process. 5S, I think everybody on this call is doing 5S or 6S. If you add safety to it, everybody's doing Kaizen, which is the ability to make improvements. I mean, you'd be amazed, guys, because I think you take it for granted being at Olbrich, PTA, and Marion. I mean, there's companies, they cannot, if someone gave a suggestion, it would take a full year probably to get it implemented, and half of them wouldn't get implemented. I think the average of across the country is 2 or 3 or 4 implemented suggestions every year on average. So the ability to do Kaizen important. Standard work, is everything done the same way? All 3 shifts? Can I expect that? Is everything under control? Can I expect the same output, the same? And what are those things that are making it vary? So standardized work is about, applying some of this thinking with Six Sigma. Saying, all right, how do we make it where it's predictable? Where I know what we're going to get. We don't have to guess. It's not a surprise. And then Kanban supermarket thinking, again, a real powerful tool in terms of making sure that the water level, well, it's basically a signal to do work, as we learned, I think, in the 3rd section. But it's making sure that we don't overproduce. That's what it comes down to. It avoids overproduction. A visual factory, I think I have a couple examples in here too for visual factory where I should be able to walk anywhere in the plant and kind of know, are we ahead? Are we behind? And the offices also. Are we having a good day? Are we having a bad day? Are we having a good hour or a bad hour? Visual factory, you don't have to search too hard. One of my favorite examples of that is probably the vision boards at Ulrich Shape Wire down in North Haven. Very visual. Where what's coming next to to that particular cell, what they're working on right now, when they're going to put new maintenance. They have the success checklists on those boards now, and really cool visual factory. So you guys are familiar with this, so I'm just going to just touch on it quickly. Sort, set, shine, standardize, sustain. There's the Japanese interpretation for them. If I'm going to clean out my pantry I did it a couple. I'm going to 5S it, I should say. My wife was down the shore, and I always find like I think I found 3 or 4 bottles of A1. One of them was stuck to the cabinet. So I usually wait till my wife is out of the house because you don't take lean home unless you want a divorce. But I decided I was going to take the 5S. So the first step is sorting. Take everything out of there. And that's when I discovered. I think there was 2 or 3 white containers of marshmallow fluff too. One of them was stuck to the shelf. And then I looked at expiration dates. Like everything comes out of the pantry. Everything. So I had the kitchen counters. I had nothing to do that day, huh? That was a couple weeks, 2 weeks ago. He was down the shore. So now I'm gonna so sort means anything that doesn't belong doesn't go back in. Everything comes out, and the only thing that goes in there are things that belong there. So I mean, there was food from canned goods that expired in 2018. There was like I said, 2 or 3 things of marshmallow fluff. There was from when the kids were little. Now they're all in their 2 of them are in their 30s. Um, and basically now when I put it back in, everything has its own place. That's where the Satan straightening comes in. So sort, or sometimes it's called set, and that's where labeling, um, that's where shadow boards, all that stuff comes in. Then while I had it done, I noticed that there was a buildup of spilled marshmallow fluff. Maybe I can take a sponge to the wallpaper that she had on the shelves in there, and paint maybe the sides of the walls. Um, Sweep down the bottom of the thing. There's 2 doors. You don't have the floor, like a floor underneath. And then standardize. This is what you don't do this at home. But as you guys know, standardize to me means checklist. So we build a checklist. Exactly how do we want this area to be? And I think the key thing here is we gain agreement with everyone that works in the area. And this is really about visual control and standard work. 5S is not really about housekeeping. It's about not having to search to find A1 or salad dressing or whatever the heck is in there. And then the last thing is sustaining. That to me is code for audit using the checklist that I made in the standardized step. And I think you guys are pretty well in tune with that process. 5S, sort, set, shine, standardize, sustain. And there's some benefits of it. Again, it comes down to time management, not searching for things. Because I think sometimes we get bogged down with the idea that 5S is about housekeeping, and visitors coming in and seeing nice area. That's one of the icings on the cake for it. But largely it's about being able to do faster setups, spending less time doing motion, walking and finding things, waiting, the whole 9 yards. And I'm going to skip by these because I covered them already. And the visual factories. Hey, look at that. There's John and Joanne Marie. You guys probably recognize the bottom left picture. That's wire. This is the fan and the rewinder, and those are magnets. And anybody can walk over there anytime, and they know exactly what they're working on, what's coming next. The schedule is posted there. They've also posted now, like I said, the 5S results for that area, for those areas. But everything's in one place. I don't have to ask anybody. I can just walk in, and really simple to see where they're at, what they're doing. I keep the one on the right. This is a really simple one. This was Bakery on Main up in East Hartford. Really cool little company. Their founder just passed recently. But they make gluten-free oatmeal, granola, and granola bars, and they sell it into Whole Foods and other big Stop and Shop. I think you'll still find it. And they have a real simple in each area. This happens to be, I think the oatmeal line, maybe batches per day, yield. And I think Marion has a pretty cool board like this also, where you kind of understand, is the car right down the middle of the road at 70 miles an hour? Or are we off into the rumples, the strips on the side? Are we overheating an oil? We kind of know where the car's at. And this is updated daily. You can see it Monday, Tuesday, Wednesday, Thursday, Friday. And this all rolls up into 2 or 3 or 4 items on a dashboard. for the whole company. So each area contributes to the overall dashboard. And you know you had a good week. You don't have to wait until the end of the month to find out we struggle a little bit. So visual notice of status, visual notice of variation, and then a lot of times you couple this with gamble walks. So first thing in the morning at 7:30, all the people at the managers at Wire, they do a walk around the plant and they look at each of these boards and they have a few words with the operator. What do you need? How things look? Any problems? Can we help you? That kind of stuff. So it kind of ties together with doing Gemba walks on a daily basis and doing standard work, leader standard work. So these are prerequisites, and standard work provides consistency. And again, I think Brandon's on the call. With the project that he's dealing with, you're not going to want to find out in the afternoon that you had a bad morning. And it helps. It just helps you know that we're at tact or slower than tact or behind, and it does it in real time. It doesn't do any good to look at a report at the end of the month, to find out that the car was out of gas on the 12th of the month. So it's like I want to know we're out of gas right after it happens. And again, consistency is required. Someone has to make sure that it's important, make sure it continuously gets posted. And the way I did it in my business was, we started out, obviously I got a monthly report each month in our management meeting. I put my glasses on. I tried to look smart, study it for a while, but I couldn't. I couldn't tell. What can we do now to change anything that happened in the month of July, for example? Once we started doing this, and I say, all right, let's look at week, and then we look at day, and then we look at morning and afternoon, and then we look at hour by hour charts, which we're going to kind of touch on a little bit next week when we get into the control charts in the control part of this class. So Improve, this is an A3 board on Southington from a few years ago. But it's basically, you guys have all heard me tell you that Kaizen means change good. No. The pictogram on the left is somebody with their back to you, whipping themselves with two whips in each hand. And the one on the right is a ox at a altar for slaughter. So Kaizen really means self-sacrifice for the good of all. This company here, I think 200 employees at least, like 180 employees maybe. That's why they have so many. This is kind of similar to what Ulbrich would look like right now if you put all the divisions together. So Kaizen events. I think, some companies, this is how they do lean, but I just found in my own business that you can't do enough of them, right? Because I feel like business is death by a million paper cuts. If it was one or two big things, we would already figured it out. We're not dumb. But I think Kaizen events have their place. This happens to be one in Illinois last summer. Do I have anybody from Illinois on the call? I'm not sure. I know we have in a class we do. But again, by the time we show up, current conditions already done. We've gone through define, measure, and analyze. And then all these people came to Illinois last summer, Albrook of Illinois, and we already knew what we were going to do, which was to try to figure out, increase the productivity of this particular slitter that everybody's standing in front of. We have a similar event going to happen in Mexico. We're planning one at PTA in Colorado. But I think they're a good thing to do. I just don't think it's a steady diet because I had much better success to the bottom line just listening to the operators. People are doing the work, taking seconds, minutes, hours out of their processes. But the good news is when I get good at doing A3, then I get really, really good at doing Kaizen because people are used to working in teams. There's no power struggle. Because if you look at what some people, when they go out and they do Kaizen events, you spend the first day just trying to control everybody, talking over each other and all that. You guys, as you know, that doesn't happen in your companies, because people are just so used to working in those 3 to 5 person teams. So I feel like A3 first. And then, all right, I think it probably makes sense to do a mapping exercise down in Mexico or whatever. Kanban, I'll cover this quick. A pull production scheduling, only produce products with exactly the same amount that customers want. The just-in-time idea. I don't want to overproduce. And it's basically, it means light or signboard. Originally developed by Taichi Ono when he saw the American supermarkets. He was enthralled with them, because basically what gets shipped out the door, that's what gets replenished on the shelves. No more, no less. If I sell 10 cans of Campbell soup, 10 cans go back on the same shelf. He was just fascinated by that, believe it or not. That's the whole idea is make one, build one, use one, buy one. And you can't get the single piece flow. That's just in time. That's where supermarkets come in, where I have to have a controlled, timed inventory, a time-based inventory to make sure that A, my cash isn't sitting on the floor, and two, I'm not damaging it or transporting it or counting. Think about the amount of time spent just verifying that my inventory is correct. It's unreal the amount of work that I did in my business. And I had a small business, like 32 million in sales, 70 employees. But we did ABC counts. We did like an annual inventory, shut the place down for 2 weeks. Not 2 weeks. We'd go from like Christmas Eve or 23rd of December, have a Christmas party, then we'd be done with our inventory by the new year. Clear out the system, go out and count everything in teams, the whole 9 yards, and just think about how much time. And then you lower in the water level, which is what my hero Taichi Ono always said, is the first thing you do is lower the water level, which he meant inventory, finished good and raw material. Because now I don't have all that waste. And it doesn't, inventory hides problems, is what he said. So by lowering the inventory, my problems become exposed. And Kanban card, ticket or signal to authorize production. You guys are all familiar with how that works. Okay. So I'm going to show you a bunch of fun slides. It means mistake proofing, right? Because again, one of the themes in lean is people are smart and people care. If they're making mistakes over and over, well, then let's take a look at the process, see if there's something we can do to make it more mistake proof. They used to call it foolproofing. That doesn't fly. But that's what Poka-yoke means. There's a couple ways to do it. Use a shape, color, size, or any other physical attributes of the items, constant number method, sequence method. You see a lot of these things in everyday life. On the left, any idea what the mistake proofing is in these gas nozzles? Anyone?
Diesel. They don't fit into one another.
Yeah, I can't put diesel right in the gas, Brandon.
Yeah.
Exactly. That used to happen. So that was a big mistake, right? Because all of a sudden you had to have your motor worked on, or the car would start smoking. I never did it, so I don't know exactly what happens, but not good, I don't think. Your car is full of mistake proofing things. Any idea the filing cabinet top right, you can only open one drawer at a time because there used to be trips to the emergency room. When people would open two or three, they end up falling over on them. The dead man switch on everything from chainsaws to mowers. People used to go to the emergency room because something be stuck under the mower. It would still be running. The blades would be turning. They try to dislodge it, and their finger would become dislodged. I mean, your gas gauge, your car right now, it yells at you, beeps at you, lights up, the whole 9 yards. My favorite, absolute favorite mistake proofing device ever is that little piece of plastic that's holding the gas cap on. Years ago, people used to take the gas cap when they were filling up, put it on top of the car, then go drive off. Guilty as charged. And then you'd have to go to 7-Eleven or somewhere, Cumberland Farms, and they actually sold gas caps until some Nobel laureate decided, hey, I got an idea. Let's put a cord there. Beautiful. That, my friends, is the end of Improve. Wasn't that a lot better than all that hypothesis testing we did?
Oh yeah.
Yeah, a little bit of a review, but so the homework again is if you can go in to do just it should take long at all. Let's see what it looks like. I think it's gonna be a mess, but let's do regression in the
So
data
just
pack.
a note about the homework, Bill, you've got some blanks in the pulse section,
Okay,
and
thank you, Devin.
it causes the regression chart not to work.
All right, thank you, Devin. Did you fill them in like just randomly with something?
Yeah, I did.
Okay, yeah.
for mine. Yeah.
All right, thank you so much. I'll go back in and maybe I was messing with it, deleted one or a couple of them maybe. So I'll go through and do that.
Okay.
Oh, you know what I think it might be? Because I think when I do my physical, when I have a physical, there's my weight and I don't think I do the pulse when I do my physical. Maybe I don't record it when I do that. All right. Good to know. Thank you. Well, have a great rest of Monday, people. Hope you enjoyed today. 41 minutes. I'll send you the recording and the math practice. If you need any help, please reach out to me, guys, especially if you're a little bit behind. I want to help. And I'll do a Zoom at last minute notice. I'm gonna probably pick captains, for the teams, get that going. And down the stretch we go. Have a great night.
See you, Bill.
See you,
Thank you,
Bill.
guys.
Bill.
Thanks. Take care.